Hello everybody, it's time to move on to the next topic within mechanical vibrations, and that is the vibrations of circular shafts. We will restrict ourselves to the analysis of circular shafts, so that means the cross-section of the shaft is circular, can be hollow though, as long as it's circular. For that we will derive the equation of motion, and we will see that the mathematical form is again this wave equation. So all the techniques that we developed for the analysis of strings and bars, we can also apply them here. So for that reason, I'm not going to do all these lectures on deriving natural frequencies, orthogonality, free and forced vibration, because that is very, very similar to what we have done before. So what I'm going to do is just a single video in which I derive the equation of motion. And then you will recognize this form, and I think how to do the rest is then self-evident. So before we derive the equation of motion, I think it's good that we have another look at this shaft and how we are going to describe deformations in this shaft. So how to basically set up the kinematic model. This is actually the same as what we would do for statics. So problems in mechanics of materials use the same kinematic model. And that is that for circular shafts, it is fair to assume that each cross-section, so each vertical line you see here, remains vertical throughout the deformation. So yeah, well, let me just demonstrate it to you. I apply a torsion moment. You see that indeed the vertical lines remain vertical, okay, but that each cube that was initially square now deforms like this in a deformation of pure shear. So we have only shear deformation, shear strains, no normal strains. For this, it is very important that we limit ourselves to circular cross-sections, because only for circular cross-sections the stress distribution will vary linearly with the radius. So the maximum shear stress is at the outer radius, and because of the radial symmetry, this is evenly distributed through the cross-section. So because of this evenly distributed strain, there will not be any deformation in the out of plane direction, in the actual direction. So for non-circular cross-sections like squares or rectangles or whatever, you will have this out of plane deformation that is called warping, but that we will not consider in this course. How to do that typically is discussed in master courses. So again, only shear, and the magnitude of this shear depends on how far we are from the center line. I will develop this kinematic model and required math in this lecture on deriving the equation of motion. You will recognize the same steps, I hope, but the physics is of course slightly different. But I think you will manage. So just one lecture this time, and then I will come back to you when we discuss the next topic, which will then be the vibrations of beams. Good luck, see you next time.